You and I will not make garbage. We will produce a chemically pure and stable
renderer
that performs as advertised.
Hello, and welcome back to the Vulkan series. Now, we've got our program from before. We're drawing a bunch of triangles using the push constants. And it's all good, it works, we have some frame rate. We have an issue. If we minimize this, it crashes. It says we've got an unhandled exception, which is this incompatible display. So it turns out that OpenGL sort of holds our hands quite a lot. When we make a program in OpenGL, it creates a frame buffer and everything for us, so that's all good. And when we minimize a program, that frame buffer actually gets destroyed and recreated. Actually, the whole swap chain gets destroyed and recreated. OpenGL does this for us, Vulkan does not. So the task of this video is basically to handle resizes, minimizes, and all of that to recreate the swap chain. There's a fair bit of things involved, but let's clear this for now. Basically, we're going to start at the engine, and we're going to take a few of these processes and break them up into other bits. So let's jump in. Actually, let's declare the functions first. So making the device sort of involves creating the swap chain components. So let's make a recreate swap chain function in this scope here. Now, if we go to the recreate, where are we? Make device. Part of recreating the swap chain is basically creating a new swap chain. So let's take the task of creating a new swap chain, put that in its own function, and that means we can reduce some of the code reuse. So we'll also have, put it above. Okay, and another part of making a new swap chain is destroying the old swap chain. So just make a function here. And I'll worry about the other stages later. So let's go to the cleanup function, which should be down the bottom. Okay. And basically, these tasks here are the tasks involved in cleaning up the swap chain. We go through each of the frames and we delete the objects which are stored in that frame structure. Then we go and destroy the swap chain. So we'll just make a function which basically does this. So grab all that stuff. And we'll clean up the swap chain. Okay, let's just give this a test and check that it's running. Okay, it's looking good, and when we destroy, the swap chain is cleaned up with no errors. Okay, so I'm happy with that. We can close that down. Now I'm going to make the make swap chain function. Okay, so now if we look up above, we have this swap chain bundle stuff, and we won't worry about the frames in flight. Let's grab all of this. Well, actually, sorry, we will need that because it's based on the swap chain number of images. So we'll grab that. Okay, alrighty, so we're using that function, give that a shot. It works well, there are no errors, all good. Okay, but if we look back at the frame struct, we haven't just got the swap chain frames Okay, so create Swapchain. There we go. So for each frame, this create Swapchain function is basically setting the image and the image view, but there are other objects in the frame struct which are not being created. So this is just making the image and the image view. We also need to make a command buffer, a frame buffer, a command buffer for each Swapchain, as well as these semaphores. So there's actually a little bit more to do. No problem. So what we can do is go back to the header. And the other objects were set up in Finalize setup. So part of that was making the frame buffers and making the synchronization objects. These ones are going to go in their own functions because we need to reuse them, both from create Swapchain and recreate Swapchain. That makes sense. Okay, so now we'll go to the engine and look at the Finalize setup. Now, Finalize setup is basically this bit here. Okay, so looking through here, we're looking for making frame buffers, and that is pretty much these lines here. So we can, just double checking, looks good. We can grab that and put that in our make frame buffer function. Okay, looks good. So again, let's test this. Okay, that's looking good. No errors. Close that down. So the other one was making the synchronization objects. Now, before we had this make command buffers, and that made a command buffer for each frame, and it also made a main command buffer, which it returned. And I'm actually going to refactor this. So go to the commands function, and we can actually reuse the same struct here, because in the case when we're making the main command buffer, this will either be something or it'll all be null, and that's fine. We're just going to ignore that completely. But there is some benefit to not typing code out again. So, oh, by the way, I've added comments for these. Just check out the code in the link below if you'd like to check those out. Okay, so going to go back to the original make command buffers, and I'm going to change that to just make command buffer. Now this is going for each frame. We'll get rid of that. And so this function is just allocating a main command buffer, doing nothing else. So we can go to our engine and set that up. And then we'll call this function again. And this will take the same information and populate the frames with a command buffer each. And it's really just reusing the same function. So then we can go down, and I'm going to call this make frame command buffers and just remove the main command buffer section. Okay, so now what this is doing is we've got the same allocation info because we're allocating stuff. We're going to loop through the frames and make a command buffer for each of them. So as you can see, we've sort of split this into two different parts. And this should be void because it's not returning anything. Okay, that looks good. Now let's give this another go. And yep, as before, it's working. Close that down, no errors. Okay, excellent. Now the last bit is making the frame synchronization object. So that's sort of just in this block here. So we'll go void. Okay, cool. So it's just looking through our frames and creating the objects. So we can call that. And by the way, all of these work because when we recreate the swap chain, that where are we? That make swap chain function will be called first, which sets up the array, the vector of frames. This swap chain frames is used in all of these functions down below. Okay, so let's give that a shot. You know, I'm surprised that this isn't erroring out. I often make more mistakes than this. Looks okay. Close it. No errors. I've jinxed it now. The next thing I do is going to be a massive mistake. So let's sort of shrink this down a little bit, make it more visible. Okay, so we have all of this stuff. Okay, so this makes swap chain. Okay, after we make the swap chain, let's recreate the swap chain. Okay, so what will we do? The first thing we'll do is we'll clean up the swap chain, and then we'll make swap chain. That'll make a new one. And then before we couldn't do these all in one because we had to create various resources first. For instance, we needed to make the command pool, for instance, before we allocated command buffers, and so we couldn't just chain these all together. But now those resources have been created, we can just go for it. Okay, then I want to make the command buffers, and that was sort of an inline operation. So if we go back down to finalize setup, I set up that these ones here. So we have that chunk and making the frame buffers, command buffers for each frame. Okay, so what do we need to do now? Well, this function will recreate the swap chain, and I'll test that in a second. But we also want to identify when the swap chain needs to be recreated. So this is a little bit fiddly, I guess. We'll go to the render function and have a look there. Okay, now I just realized that I should probably not reset the fence as soon as I get it. It might be a better idea to go down and reset it here before we submit the graphics queue. Let's see how it goes. Okay, but where was I? So I want to acquire the next image. Now it says that this returns a Vulkan result value. So if we click in here and look at this Vulkan result value, this is a structure which has a result and a value. Now this result is a Vulkan result, a VK result, and this T is just some sort of value, whatever the regular function is meant to give. So what we can do is we can say, okay, we've got the image, and we got the image indexed by unwrapping, getting the value. Let's get this. So let's say value, and the name of the task is acquire, and we get that by calling this function. Then we can say get the value of acquire, and what we want to do is we want to test the result. So we can say if is, what is it? It's Vulkan result. For some reason, static checker doesn't like it, so we go enum error out of date, meaning the swap chain is out of date. So if that happens, recreate the swap chain and return. We're not going to do any error, or we're not going to do any rendering at this point. Yeah, it's fine. Actually, I'm umming and ahhing on this. Let's just go with this for now. Okay, so let's give this a go. Alrighty, it's working, but it's meant to work right now. So if we minimize it, oh no, we get an error. Okay, that's not so good. So see that these results are sort of, when they come up, yeah, we have this sort of throw result exception. So there's kind of something working under the hood. When a result has been set, if the result is not Vulkan OK, then it'll sort of throw one of these exceptions. So instead of simply checking for, and this happens by the way when a function ends. So we can set result variables by hand, but if it comes from a function call, then an exception is thrown. So instead of that, let's try just actually, let's put this in a try catch block. Okay, so the thing that we're trying is we are trying to set this. And it's probably going to complain that it doesn't know. Down below, if we try to use image index, it'll complain that it doesn't know what it is. So we'll just declare it ahead of time, set it in here. Okay. So the next part here is we want to catch an exception, and the exception it's going to throw is a date error. Okay, cool. So let's give this a go. Alrighty, we got that. And it doesn't work so good. And this is pretty frustrating because we are catching that exception. To be sure, we can sort of print this out. So we can go... Okay, so if you get to this block, we've caught this exception, then we're going to execute this. Okay, so we get the error, and if we check the terminal here, we have not gotten to that. So that's really frustrating because it's not actually throwing an error at this point. Okay, so there's sort of the issues where we could fail is when we're either grabbing something from the swap chain, could be out of date, have been resized or something, or when we try to present to the screen. So at the moment, the errors which are being thrown are not errors from grabbing an image, they're errors from trying to present to the screen. So we'll just go down. Now at the moment, this is called acquire because that's the task that we're trying to perform. Now if we go down here, see it says here, return value ignored. And it says, what does it say? That this returns a Vulkan result. So let's do the same thing again. Let's say, okay, and the reason we couldn't do this before is up here. So if we declare this, declare it like that, it says, hey, we don't really have a default constructor in this sense. And I think actually what they want is they want the type name. Yeah, let's not worry with that. It's probably like something something. That's fine. So down here we have present. And then what we can do is we can do the same try except block. Okay, now the reason I'm not immediately calling this function is that we might actually have several things that we're checking for. Remember that setting a Vulkan result by hand is okay, that won't throw an error. But for whatever reason, setting a Vulkan result as a result of calling a function, does that make sense? That's the part that throws an error. So what we can do is we can say test this, so we go I don't know why it keeps auto-correcting this. How hard is it? Okay, so where were we? So there are other things we can check. We can actually set this by hand. But another one we can check for is suboptimal. So that's not an error. That's just a sort of a warning thing. And then we'll do the same thing. So if we go back. Yeah, we'll just recreate the swap chain. So give that a go. Okay, that looks alrighty. Minimize it. Oh, it works. It wasn't supposed to work. Okay, so well, it's working, but we're getting errors. So, by the way, it's supposed to be throwing an error. I'll talk about that in a second. But what are we getting here? Oh. There we go. Here we're getting an error. Okay. Destroy semaphore. The semaphore is... See, this is an issue. This is an issue. We can't destroy the semaphore if it's currently in use. Now, why is that semaphore currently in use? The semaphore is currently in use because the swap chain or the graphics card is still doing work. So this part is fine. What we want to do is we want to go to device and just wait for that to be idle. And then after that's done, it will do its thing. So here we have it. It's working. Can minimize it. Uh-oh, we've got another error. Okay, what does it say here? Validation error. Width must be greater than 0. And that makes sense. Of course, width must be greater than 0. What are we doing right now? We have kind of got the frame, but we've minimized it so it has no width. So when we recreate it, that's perfectly fine. The issue is it's trying to recreate the window when we have no size. So we can just do a little test here. Again, this is one of those sort of standard bits of code. We're just going to wait. So we'll say okay, cool. So we just sort of stall it in the windowing library until we have a valid width. So we run this. Okay, that's fine. We minimize it. No error. It says recreate. It's waiting to recreate, and it will recreate now. And yeah, we can see no errors. Nothing. Yeah. That's pretty good. That's pretty stable. What we can also do is we can go to the app, and in the app, when we build the window, let's set resizable to true. Okay, now give this a go. And there we have it. Now note that it is sort of not quite resizing the window. Also interesting to see is the memory usage. So if I resize this, maybe not that much, we can see that we're using extra memory. And then if I take it down to the smallest possible, give it a second, memory usage drops as it frees that up. So yeah, that's very cool. Very cool.